The previous two lectures introduced the applications of first-order circuits in signal processing. In this lecture, we will introduce the application of energy processing, that is, rectification and chopping. You will be surprised to see that we can easily change from the form of energy with a switch and energy processing unit. For example, change 12 volts DC into 5 volts DC. We need to point out that the change of the form of energy is between AC and DC. It includes a change from AC to DC, the change from DC to AC, and the change between different DC voltages, and the change between different AC frequency. In the fourth part, we can change AC to AC directly, and we can also change AC to DC firstly, and then change DC back to AC with different frequency. In this lecture, we will discuss the change from AC to DC and the change between different DC. Firstly, let's review the bridge rectifier in lecture 42. Suppose the diodes are all ideal, which means it's short circuit in half cycle and open in another half. Suppose the input is a sinusoidal wave. According to the discussion in 42, we know that at any time only D1 and D4 or D2 and D3 can conduct. So the current is always positive, and the voltage of load is always positive too. This is a waveform. But the voltage fluctuation is too large to meet the real demand. So how to improve the performance of the DC voltage in bridge rectifier is a very important and realistic topic. In lecture 46, we will discuss that the capacitor has the property of keeping voltage constant in a short time. So our thought is to add a large capacitor shunted to the load of the bridge rectifier in order to improve the performance of load voltage. Let's analyze it. When US is greater than 0, D3 and D2 are open and they can be ignored. The circuit is like this. Let's draw the waveform. This is a waveform without the capacitor. We suppose the capacitor's voltage is some value at t equals 0, and we don't concern this part firstly. Seen from the load, the source voltage is on its left side, and the capacitor's voltage is on its right side. If the capacitor's voltage is greater than the source voltage, the two diodes are open now, and the capacitor discharges to the load. Once the source voltage increases to be greater than the capacitor's voltage, the source charges the capacitor and supplies power to the load. When the source voltage reaches to its maximum value, US decreases and the capacitor discharges to the load. The capacitor is very large, so tau is very large, and the discharge speed of the whole RC circuit is very slow. The change speed of the sine wave is faster than that of the RC circuit, so UC is greater than US quickly. D1 and D4 keeps open, and the load is still the first order RC discharging circuit. When US is less than 0, D1 and D4 are always open, so they can be ignored. The current flows in this direction. After adding a large capacitor, in the time period of US less than 0, if minus US is less than UC, D2 and D3 are open. Only when minus US is greater than UC does the source charge the capacitor and supplies the power to the load. The following process is the same as the previous one. The load voltage form has two significant improvements compared to the previous one with large voltage fluctuation. One is high average DC voltage, and another is a small DC voltage fluctuation. We have a question for you. This is a straight line in the diagram, but RC first order discharging curve decays with negative exponent. Why we can use this straight line to represent the curve decaying with negative exponent? The large capacitor realized the function of smoothing voltage wave, so it's called the smoothing capacitor. We've done experiment of the bridge rectifier with smoothing capacitor in lecture 42. Let's review it. This is a bridge rectifier formed by diodes, which can change AC to DC. This is a circuit. The input is AC voltage. The output is the voltage of the resistor. Two channels are isolated by the op-amp. We use oscilloscope to observe the voltage waveforms of the input and output with smoothing capacitor and without. The two conditions are controlled by the switch. Now this is a voltage wave of the input and output without the smoothing capacitor. The output is DC with large fluctuation. Now we switch on the smoothing capacitor. The output becomes smooth and is a relatively ideal DC.